Assalamu alaikum, hello viewers. Today we'll be discussing about a vertical axis wind turbine, and for some of the basics about that we'll be going through some basic elements of an aerofoil, since it's one of the most important design considerations of any kind of wind turbines or any kind of turbines. And the similar thing is also allowed for hydraulic turbines, since they are treated as a common fluid. But for that case we call it hydrofoils instead of aerofoils. So aerofoils are basically streamlined objects where fluid streamlines are assumed to be less separated from the surface of the solid. From the solid that isn't streamlined is called a blunt object, and the one which has some kind of tailing or streamlining is called as an aerofoil or hydrofoils. For example, if we just choose the front plane and extrude something out here, if the streamlines are like this, sorry about that, if these are kind of hydraulics or fluid streamlines, they would tend to get separated from the solid body at the downstream edge. But if we can make something that is tangent like this extra bit of area would reduce the tendency of the fluid to be separated, and this is called streamlining, and this reduces pressure drag up to a huge amount, even though this process kind of sometimes increases the skin drag or friction drag due to the fluid viscosity, but that would depend upon the length of the streamlined object. That means this extra bit of portion that you need to add to this blunt object to reduce the pressure drag. We will be discussing in details about aerofoils in some other kind of videos, but for that we just make our discussions limited to that's needed to this design. For that we remove this part. Today we will be using one of the standard features, standard aerofoils that you might just use many of the standards. They are very standards, but today we'll be using specifically NACA airfoils. For that we can utilize direct data points from the standard database of the NACA airfoils. For that we just Google the standard NACA airfoils database. We go to that and we just, for the first time, we just go for the 4-digit airfoil database search. Here you can see some of the previews of some of the standard curves. Let's see, for the first time we go for this one. And copy all the data points, Control C to copy it, and just make a folder where we wish to save it as Microsoft Excel file. Open a new Microsoft Excel worksheet. Let's say just airfoil. Today we'll be importing these data points directly to the Solidworks interface, and for that we'll be using the import and curve through XYZ points. Let's paste it all the way. For Solidworks, that's just for the preview. For the first time, if we activate this feature of curves through XYZ points, it demands 3 coordinate axis points. So since our coordinate axes are on 2D axis and be projected on a single plane, so we need to make the other axis as 0. Just pull it all the way down. We can make all the rows as 0. Now we need to save it as a comma delimited file instead of an Excel file. It's comma delimited file, CSV.CSV file. Let's save it as CSV file, and we'll go for the aerofoil.csv. Just demand and warn you about the capacity as well. Now we close it. And here Solidworks, for importing this, it would take only .sld curve or .txt file. For that we'll be using .txt file, but we need to utilize this .csv file into csv.txt file. And go for yes. And now we use our file.csv.txt. There we have our curve. Pretty good enough. It's okay. Now for the vertical axis wind turbine, we'll be using this front plane as the vertical or the top plane instead of the front plane, but either way you go, it would be the same. You can just turn it or set it around which you want, project it out to the plane you want. But for the simplicity of this tutorial, we'll be just going through just utilizing this as the top view instead of the front view. So we just make a sketch on it. This would be the base. Let's set this one as 3.6 meters. Move this to a position that this curve is at an edge, since we want this to be on the sides and it would be acting as a blade of the wind turbine. So that's it, good enough for us. We extrude this, and for now we'll be extruding it up to 2 meters to represent that there are other things like the rotor, the stators, the generators inside this part, but we will not be showing those at the moment. For the simplicity, we'll be just going and sticking to design of wind blade only. So for that, another thing to be noted, the more you can utilize this cross section, the more we get a positive lift, and for that we might just go for a helical blade. For that we use this edge as sketch and sketch on this plane, convert the entities. There's a circumferential circle, and utilize this circle to produce a helix. Let's see, the more the pitch is, the higher is the distance you go. So let's say for the time being we want a 10-meter pitch. And the revolutions, well, we'll say 0.5. Alright, maybe we're gonna force. We could just always edit this position wherever we want it. Now we need to project this curve on this plane. So for that we start another sketch, select this curve and select the convert entities. This would allow us to make a swept boss base that would follow through this path. Now we select the swept boss base, this as profile, and the path would be this one. And since these two are not piercing, this is not taking the command. For that we need to pierce it out. Let's do this. We need to modify this helix. The start angle, let's say it would be 0. Where is the position? 90, or maybe 270. Yeah, much better. Now let's go for the curve and the profile as this one. Since they are oppositely connected, so the Solidworks wasn't taking the commands. Let's see how this works. See, from the front view, the more we can utilize the positive lift of this curve, the more is the available power that we gain. So for that we'll be using the area up to this, and will not be using this area, since it might just cause a negative drag as well. Someone might just use it, produce extra drag that would follow through this path. For the time being, we might just leave it as it is, so it won't just matter much. Now we produce another top surface that would hold the blades together, because if it doesn't hold it together, these tips would always tend to bend when the fluid is flowing through this, and this would cause always a moment of inertia and a moment about this fixed surface, and it would at one stage would cause fatigue failure to these blades. So for that we need to fix this surface as well. For the time being we'll be using a reference geometry that would be used to produce the fixed support of this end. We just select this plane and let's say just increase the distance for about 5 meters maybe. Yeah, good enough. And we produce a sketch on it. using the normal tool. We might just could convert the surrounding entity out here as well to ensure the similarity. Now we just extrude this part a little more, but this isn't gonna be that thick because it would only increase the drag, increase the load upon the structure. So for that it would just might be 0.25 of a meters. Now we just hide the planes and the curves. Much better. Now there's a problem in, that might just cause a problem in patterning these blades. Usually they are checked to merge results. That means when you tend to make patterns of these kind of shapes, they would also make the patterns of the elements that they are merged with. So for the time being we uncheck the merge results option and produce a circular pattern. For the parameters we select this circle, and 3 blades would be good enough. Let's see the preview, and since I have unselected the merge results, we might just need to select the bodies to pattern and select this body there. Much better. These helical shaped elements would act as blades that would cause the extraction of energy from the wind. Now we need another sketch to support this structure out here. For that we just utilize a sectional view. Good enough. And now we draw a circle to produce a structural support like columns or something like that. We select the radius to be 0.6, that means the diameter will be 1.2, and now just extrude it. Before that we just close the sectional view and extrude the sketch up to this surface. From the sketch plane up to next would be this same thing, and even if we selected up to surface, that would be up to this as well. And even if we just uncheck this one and selected this surface, it would produce a circle up to this point. Now let's say we want to cut some of this boss a little bit up to this one. So for that we might just have a reference plane and make a revolving sketch on it. For that, for the first reference we choose the top plane. For that, let's just turn on the temporary axis, and now let's choose the plane as top plane, and the second reference would be this one, and so let's choose this one. That's good enough. Set this one as parallel to the top plane, and this would be good enough for us. And we start a sketch on it. a center line from this one to this part, and now we wish to trim out up to this part. So let's say we want a rectangle which is going to start from this line to this one, and now we just go for the revolved cut. There, good enough for us. It means up to this part it would rotate, and the lower part would only hold the static parts of it. So let's just hide this plane and also the temporary axis. So that would be it. If we wish to add some material to it, let's say we want some aluminum alloys, even though these are usually made up of fiberglasses, but for the time being, which is the properties are more close to the fiberglasses, we will be using some of the aluminum alloys, since they have a higher load bearing capacity with a lower weight. So let's say for the we go for the first material and just apply it, and if you want, you could have just changed the appearance as well, play with it, some of it. Let's say we want some plastic look, maybe. Let's say we want the blades as blue. Similar thing we apply for this circular pattern. There, and we might just go for some stone material, maybe for the ground part, and for the upper part let's just go for wood. It's just some kind of appearances only, nothing else. It could have been just more like been used as some kind of furnitures, since the appearances if you wish to make, but this would be up to you in which application you use. This would be all for this part of this video, but in the next video inshallah we'll be uploading a slight simulation of fluid interaction of it across these blades and this structure. So that's it for now. Thanks for watching, and if you have liked this video, please hit the like button down below and subscribe and share as well. Thank you.